Weather variables are very important in plant health. For plant pathology, forecasting of diseases and plant pathogens becomes very important to try to manage and anticipate the problems that our producers will run into. I have a weather station here. This is made by Campbell Scientific. This is called the CR10 unit that we have set up a network around the state. We have a network of about 40 of these stations located primarily in irrigated areas where we can monitor macroclimatic weather variables, things like temperature, rainfall, wind speed, for example, and relate that then to the crop development and, more importantly, pest development, combined with IPM and good scouting procedures. What I'd like to do is show you some of the components involved with this CR10 unit and how this is then utilized by plant health specialists back at the university and around the state. This unit is mounted on a tripod, which is actually in this case buried in the soil. It's about 6 to 7 feet in height. We're measuring a number of variables. In this box we have the data logger, which of course is the heart of the unit. This is then attached to a variety of probes that we can add to these units. In this case, for this weather station network called Coagmet, we've added standardized probes so that each station has similar probes. We can use similar programming to record and retrieve data. For example, this gill shield contains an instrument that will record air temperature and relative humidity according to the interval that we program. It can be every few seconds, it can be up to every hour. We can record the temperature that is occurring at that particular time. Over on the other side, we have a tipping bucket rain gauge. Again, this will record moisture as it accumulates. Snow can be recorded if it accumulates and melts quick enough, but generally this is just used for rainfall. We have, of course, anemometer for wind speed. We get wind direction with this vane over here. Up on the very top, there's a small silver plate with a little black knob that has a pyranometer that records solar radiation. Also, we have some cables going into the soil at various depths that will record soil temperature beneath or around this entire structure. Some units will also have a way of getting power to it. In this case, we're directly hooked up to a power line. We also have a battery for backup in case we do lose power. Also, we do have telecommunications. There's a little small antenna on the top of this one. You can see the little black structure up there. And then a cell phone and modem has been attached to this unit inside of this white box. This way we can then call this station, usually once a day, download the previous 24 hours worth of data, and then take that back to campus where the Colorado Climate Center will process the data and then actually archive the information, making it available to us online or on the web. Then we can come in and utilize various disease forecasting or insect forecasting or even weed forecasting models that are triggered by key events according to usually the biology and the life cycle of the pest that we're studying. Other researchers can use this data for irrigation scheduling, crop development, and a variety of other uses. So this kind of information is very valuable. A network like this that we have located around a production area will give us a good feel. We have our finger on the pulse for what's occurring out in the production region. Then by having some good integrated pest management approaches, aggressive scouting, we're able to then relate the development of the pests and the crop to these conditions. The idea being to look for activity of a pest, relate that then to these events, and then trigger some of our responsive IPM approaches. So these types of weather stations are very, very valuable to us. And we call this system Coagmet in Colorado. It's been operated by myself, my assistant Mark McMillan, Nolan Doskin at Colorado Climate Center, Harold Duke, and Mike Blue with the USDA ARS service have been instrumental in putting together this network during the last 10, going on 11 years now. So this measures macroclimatic conditions. Now we're also interested as researchers and then looking at conditions at more smaller variables or levels where we can go into a field and measure or monitor microclimatic conditions as well. Oftentimes this will give us an even better feel, a more accurate estimate of what is occurring in or beneath a plant canopy, where a plant pest, an insect, a weed seed, for example, that might be germinating, or a plant pathogen might be germinating and infecting a plant. So we have used some other equipment as well, which I'd like to show you now. This is a unit made by Mitos, actually out of Germany or Austria. It has some similar technology and probes as what we looked at with the Campbell Scientific unit. But this thing can be mounted on PVC pipe as shown here, can be taken into a plant field, for example, a potato field, and we can then bury this to a depth of maybe 12 to 24 inches to get it down close to the crop canopy. But usually this we use right above the plant canopy. And here we have our gill shield, which contains an instrument that will record air temperature and relative humidity. Here's a pyronometer located on top. You can see the little black dot here with this little plastic button. This will measure solar radiation. Of course, we're getting wind speed as shown up here. Some units can also have a vane on it to get wind direction. We have a little leaf wetness probe shown here. It's got a small piece of paper right in here, which will wet and dry according to the amount of leaf wetness that's occurring out in that plant canopy if I place this down into the plant canopy. So this will record that information as well. And then of course we have our rain gauge over here. A little different system, but again it's kind of a tipping bucket type of system. Now the data will be recorded in a small little data logger inside this unit. We don't have telecommunication capability on this particular piece of equipment. We can come in and actually use infrared or cable in and download the data to a palm top or a laptop or notebook computer periodically. So like every 7 or 10 days we can go out to the field and record that information. Now again, this unit primarily will reside above the plant canopy, but it gives us a little more accurate information in a respective onion field, for example, a potato field, which has that type of leaf morphology or development, irrigation, etc. Now these macroclimatic conditions or units like this with the CR10, we on purpose put them in kind of what we call a neutral background. That is an area where we don't have a crop canopy, we're not irrigating, so we're really trying to measure just the macroclimatic conditions. That is what's occurring out here today with the wind, with rain that we might get, irrespective of our agricultural production practices. That would be included in other types of variables. So there's a little different approach and objective with this kind of equipment versus this kind of equipment. But again, both will feed in valuable information from the research side as well as from the IPM side for forecasting pest activity and development in and around a plant field. And one other piece of equipment that we're testing this year, this is called a Watchdog Data Logger. This comes from Spectrum Technologies, and here you can see it's a very compact unit. What we do, again, we'll go into a field, let's say of onions or potatoes, we'll bury this to a depth of about 12 inches into a hole, and that will put these probes down inside a plant canopy. Then we can record leaf wetness with this small probe. Again, inside this gill shield, we have a little logger probe that will measure air temperature and relative humidity. And then here's a small rain gauge that resides up here near the top of this pole that we've mounted all this on. So this will sit into the plant canopy throughout the season, and then periodically, again every 7 days, 14 days, we'll come back and plug into it and download the data onto a palm top or a notebook computer, and then run that data in some of our pest forecast models. So again, these units are very compact, very easy to work with and put in the field. And this year we'll be testing the validity and the accuracy of the data, but we're optimistic that this will give us a very useful tool to measure in canopy, in field variables as related to the crop and, more importantly, to pest activity.
Okay, anytime you want to go.
Okay, so I'll just place this one down.
Yeah.
And finally, the Campbell Scientific Unit with the telecommunications hookup that we talked about earlier. This runs about $6,000 per unit. So I think this gives you an idea on the variety of instrumentation that is available for research purposes to record weather variables and then relate that to pest and crop development, as well as some of the more specific in-field instrumentation we utilize to study the biology of the pest, whether it's an insect or a plant pathogen that we're studying in a particular crop and disease cycle. So we've come a long ways, I think, in the last 5 to 10 years from what we started with years ago. And got one of the old instruments right here. This is an old hygrothermograph that we used to utilize. That was our only source of recording temperature in the field using horsehair and a little piece of paper and some ink. And these things were always notorious for giving us faulty data. It took a lot of people to record information and a lot of time back in the office trying to relate this to weather events, and it was a slow turnaround.